Second part of lesson 6.5 is all about the discriminant. Now, the discriminant is a word on your vocab list, so you might want to check that out. The discriminant of a quadratic equation is b squared minus 4ac. And it's useful for determining how many and what types of roots or solutions there are. And the funny thing is the discriminant is actually part of the quadratic formula. It's found right underneath that root. Whenever we take our quadratic formula or use that to solve, we're actually finding the discriminant as part of what we're doing. Now, I said that it's going to be useful for determining how many and what kinds of roots there are. So let's kind of examine that. Let's say our negative b value, let's just pretend that it's 4 plus whatever our discriminant is, all divided by, let's say 2a gives us something like 7. So those ones are just made up. So remember, our discriminant is going to be the square root of something. Let's say our discriminant equals 0. We want to see what happens then. If the discriminant is 0, we have the square root of 0, so 4 plus or minus the square root of 0. And we're either going to have 4/7, or if we do, so that's, say we did 4 plus 0 over 7, it's 4 over 7, or 4 minus 0 over 7. So 4/7 or 4/7. So in these cases, looks like we have the same exact solution. So we would say that when the discriminant is 0, there is one real, or we can even go further to say one real rational solution. So that's going to be important to remember. Now let's say that's our discriminant. So again, the number underneath our radical there. Let's say it was negative. We did one where it was negative 16. So in which case that's going to give us x is then equal to 4 plus or minus, we said it comes out to 4i over 7. So in this case, because we have plus or minus, looks like when the discriminant is negative, so this is a negative value, then we either have 4 plus 4i over 7 or 4 minus 4i over 7. So we'd have two complex solutions. So whenever the discriminant is negative, that's how we get two complex solutions. Now if we had x equals 4 plus or minus, let's use a positive number that is not a square. So we'll say something like 21 and still over 7. Well, we can't necessarily break square root of 21 down any. So we are now left with x equals 4 plus the square root of 21 over 7, or 4 minus square root of 21 over 7. So we'd say whenever the discriminant is positive but not a square, so positive and that's not a square, we'd say that there are two irrational solutions. And if we want to look and see what happens when, let's say that was a square, so we'll use 9. Square root of 9 is 3, so x equals 4 plus or minus 3 over 7, in which case we would say x equals 4 plus 3 is 7 over 7, or 4 minus 3 would be 1 over 7. So looks like when the discriminant is positive and it is a square, that's going to be our way of denoting that it is a square, that there are going to be two rational solutions. Neither of these have square roots. It's just 7 over 7, which is the same as saying 1, or 1/7. So two rational solutions. Now, if you skip ahead to the end, here is a table which also shows you the same thing. Again, it kind of notes whenever our discriminant, our negative b minus 4ac, is greater than 0, so that's when it's positive, and it is a perfect square, 2 real rational roots. Whenever it is, in this next one, it's kind of mentioning that it is greater than 0 still, so it's positive, but it is not a perfect square, and we get the irrational roots. And similar to what we said, when it's 0, it's just the one rational root. And when it's less than 0, or when it's negative, that's how you get 2 complex solutions. So those are going to be good to keep in mind while we're looking at some of these ones. Oh, so this is where we were. So if we're looking at some examples of how this is going to help us. So when you're asked to find the value of the discriminant for each quadratic, and then use that to determine the number of types of roots. So remember, discriminant is negative, or not negative b, b squared minus 4ac. If we look at this value here, we have b is 6, a is 1, and c is 9. So b squared is 6 squared minus 4 times the value of a, which is 1, times the value of c, which is 9. So we'd say that it's 36, because 6 squared is 36, minus 4 times 1 is 4, times 9 is 36, and that equals 0. So in this case, our discriminant is 0. And remember, what did that say about the number and types of solutions? That there is one real, or should I say also that it's rational solution. So in that case, we used the discriminant. We found out that it was 0, and we determined that there's only going to be one real rational solution. Let's try the same thing over here. Our b value is 3, a is 1, c is 5. So we do 3 squared is like our b squared, minus 4 times the value of 1 times the value of c, which is 5. 3 squared is 9, minus 4 times 1 is 4, times 5 is 20. So we have 9 minus 20, which gives us negative 11. So in this case, our discriminant is negative 11, which tells us, remember, anytime our discriminant is negative, there are 2 complex solutions. So those are important to remember. Let's look at a couple more examples here. Again, remember that the discriminant is b squared minus 4ac. So a value is just 1, b value is 8, c is negative 4. So we'd say b squared is 8 squared minus 4 times our value of a, which is 1, times our value of b, which is negative 4 in this case. So we simplify that down. 8 squared is 64 minus 4 times 1 is 4. 4 times negative 4 is negative 16. So we have 64 minus negative 16, which ends up as 80. Now when we have that, we want to see, is that a square? Do we know what the square root of 80 is? Now that one, it's not going to come out to anything exact. It's not going to be pretty. We can break it down into, if we wanted, square root of 16 times the square root of 5, in which case it would be 4 square roots of 5. But that's not a perfect square because we still have this radical here. So we'd say that our discriminant is 80, and that's going to give us 2 real irrational solutions. So both of our solutions are going to have a square root value in them. And looking at our last one here, we have a, b, and c. So we say our b squared is going to be negative 11 squared minus 4 times the value of a, which is 1, times the value of c, which is 10. And negative 11 squared is going to be 121 minus 4 times 1 is 4, times 10 is 40. So 121 minus 40 is going to give us 81. And do we know the square root of 81? Yes, we do. That is 9. So in this case, it is a perfect square. So our discriminant is 81, and it is a perfect square, which means that we're going to have two real rational solutions. So these solutions will not end up having square roots in them. And this will take us back to that table that we were looking at. Again, remember, this is very, very helpful to tell us our rules about when the discriminant is 0, what happens, when it is less than 0, what happens, and when it's greater than 0, it'll be one of these cases, and when it's a perfect square, it'll be the case of two real rational roots. When it's not a perfect square, that's when we'll get our irrational roots. As well on this table, we can look at our other solving methods. We can solve by graphing, which will be used sometimes because it won't always give us exact solutions. Also, when we are graphing and our parabola is above here, remember, these are the cases where we are going to have those complex roots. So from the looks of it, looking at this graph, we won't know exactly what those complex roots are. So we can't necessarily use it in this case. But graphing is still a viable method sometimes. That's why it says we can use it sometimes here. Factoring is another good method. When we have our solution and we can just break it down into the factors and solve, making each of those factors into 0, then we can solve for our solutions that way. Again, that only works sometimes, because if we had something like 5x squared plus 71x minus 13.3 equals 0, well, that's not going to be very easy to factor. So that's not always the best one to use. Same thing with our square root property. We can sometimes use it if it's already given to us in a square root form, in the x plus n squared equals m form. Completing the square, we can always use, because we can always look at our equation, whatever is given to us, and manipulate it in such a way that we can create a square root out of it. Again, in a case like this, we look at this piece and determine what we have to do to make it a perfect square trinomial. And the last one that we learned today, I'm going to star that one, we can use our quadratic formula. That will always work. It might be a little bit longer than some of the other ones at times, and use a lot more calculator work sometimes, but this one will always work no matter what, because you just have to punch things in. So in that case, we have now learned everything there is to know about the quadratic formula and the discriminant. So again, stay golden, Byron High.